Part 3. Learning outcome. Students will be able to identify the types of circuits, symbols, and devices with a bypass valve in a pneumatic system. Timing, 10 teaching hours. Description of contents by topics and subtopics. 3.1 Pneumatic devices and symbology. 3.2 Compressor, reservoirs, and service unit, FRL. 3.3 Single acting cylinders. 3.4 3.5 way valve. 3.5 double acting cylinder. 3.6 5.5 way valve. 3.7 fittings and accessories. 3.8 activities. Assessment criteria and procedure. Diagnostic evaluation. The diagnostic evaluation will take place at the beginning of the module and will serve to measure the degree of skills and abilities that students have. Formative assessment. Exam, written, oral, presentation, or projects, etc. 40%. Continuous evaluation, exercises, activities, tasks, and project presentations, 60%. Summative assessment consists of the sum of the exam and continuous assessment. Description and development of the content. 3.1 Pneumatic devices and symbology. The development of pneumatic system is assisted by a uniform approach to the representation of elements and circuits. The technical construction of components is not considered in the abstract symbol form. Symbols using pneumatics are detailed in the standard DIN ISO 1219. Circuit symbols for fluid equipment and systems. Symbols for the energy supply system can be represented as individual elements or as a combined element. In this book, simplified symbols are mostly used. The following image shows the most common symbols used in this book. The real devices associated with them will be seen in the next section's images. Pressure source. Simplified air service unit. Pressure gauge. Valve switching positions are represented as squares. The number of squares shows how many switching positions the valve has. Lines indicate flow paths. Arrow shows the direction of flow. Shut-off positions are identified in the boxes by lines drawn at the right angles. The connection, inlet, and outlet points are shown by lines on the outside of the box. Number of points, number of positions, 3.5 way directional control valve, normally closed, 5.5 way directional control valve, flow from 1 and 2, 4, and 5. Push button, roller operated, spring return, pneumatic actuation. Directional valves, actuation symbology. ISO 55993 lettering system, port or connection. 1. P. Pressure point. 2. 4. AB. Working lines. 3. 5. RS. Exhaust ports. Directional valves port connection symbology. One-way flow control valve, quick exhaust valve, shuttle valve, dual pressure valve, timer valve. Additional valve symbology. Single acting cylinder, double acting cylinder. Liner actuator symbology. 3.2 Compressors, reservoirs, and service unit, FRL. The compressed air supply for a pneumatic system should be accurately calculated and made available in the appropriate quality. Air is compressed by the air compressor and delivered to an air distribution system in the factory. To ensure the quality of the air is as acceptable, air service equipment is utilized to prepare the air before being applied to the control system. Manufacturing can be considerably reduced in the system if the compressed air is correctly prepared. Compressor types: positive displacement, reciprocating, single acting, double acting, diaphragm, rotary, lobe, liquid ring, screw, vane, dynamic, centrifugal, axial. A selection form the various types of compressor available depends on quantity of air, pressure, quality and cleanness, and how dry the air should be. There are varying levels of these criteria depending on the type of compressor. As rule, pneumatic components are designed for a maximum operating pressure of 800 1000 Kelvin Pascal 810 bar, but in practice it is recommended to operate at between 500 600 Kelvin Pascal and 5 and 6 bar for economic use. Due to pressure losses in the distribution system, the compressor should deliver between 650 and 700 Kelvin Pascal, say 6.5 and 7 bar. Although there are several compressor technologies, screw technology is commonly used for industrial applications and single acting technology for general applications. Ring circuits, as in the upper part of the picture, are most frequently used as main lines. This method is of stalling pressure lines also achieves a constant supply in the case of high air consumption. The pipelines must be installed in the direction of the flow with a gradient of 1 or 2%. This is particularly important in the case of branch lines. Condensate can be removed from the lines at the lowest point. A compressed air dryer ensures perfect drying of compressed air for the intended application and all flow rates. Since the air is designed to be high-quality industrial machines, reliable protection will be provided against condensate damage of system and processes even under the hardest conditions. Compressed air contains water vapor and it travels through compressed air piping. It cools and the vapor condenses into a liquid condensate. This condensate increases maintenance requirements and affects product quality. Some industrial pneumatic suppliers offer a wide range of efficient compressed air dryers for a particular compressed air system. The individual function of compressed air preparation, i.e., filtering, regulating, and lubricating, can be fulfilled by individual components. These functions have often been combined into one unit, i.e., the service unit of FRL for short. Service units are connected upstream of all pneumatic systems. The air service unit is a combination of the following: compressed air filter with water separator, compressed air regulator, compressed air lubricator. 3.3 Single acting cylinders. The power section consists of control elements and power components or actuators. The actuator group includes various types of linear and rotary actuators of varying size of construction. The actuators are complemented by control elements, which transfer the required quantity of air to drive the actuator. Normally, this valve will be directly connected to the main air supply and fitted close to the actuator to minimize losses due to the resistance. Linear actuators can be further broken down into groups. Linear actuators: single acting cylinder, double-acting cylinder. The single-acting cylinders have only one compressed air connection. The incoming compressed air moves the piston in one direction, and the cylinder force is built up in this direction. If the piston needs to return to its initial position, the air is simply expelled from the cylinder. The mechanical spring pushes the piston back to its initial position. This part has a ventilation exhaust hole so that no excess of low pressure is generated through piston movement in the second cylinder chamber. What force can a cylinder extend? The theoretical force of a pneumatic cylinder can be calculated using the following formula. Fn is equal to P bar times A square centimeters times 10. For example, a cylinder with a normal diameter of 100 millimeters has an area of 78.5 square centimeters. At the opening pressure of 6 bar, this area extends a force of approx 4,700 and 78.5 times 6 times 10. 3.4 3.5 way valve. The directional control valve controls the passage of air signals by generating, canceling, or redirecting signals. The valve is described by number of ports of opening, ways, two-way, three-way, four-way, etc. Number of position, two position, three position, etc. Methods of actuation of the valve: manually actuated, mechanically actuated, pneumatically actuated, electrically actuated. Methods of return actuation: spring return, air return, etc. The directional control valve is represented by the number of control connections, the number of positions, and the flow path. In order to avoid faulty connection, all the inputs and outputs of valve are identified. Pressing the push button moves the 3.5 way valve against the valve return spring. The diagram, right-hand circuit, shows the valve in the actuated working position. The air supply is now connected via the valve passage to the single-acting cylinder port. The built-up pressure causes the piston rod of the cylinder to extend against the force of the cylinder return spring. As soon as the piston rod arrives at the forward end position, the air pressure in the cylinder body reaches a maximum level. As soon as the push button is released, the valve return spring returns the valve to its initial position and the cylinder piston rod retracts. Normally, single-acting cylinders are designed in such a way that the advancing speed is greater than the reacting speed and is related to a relationship between pressure and force. 3.5 Double-acting cylinders. The double-acting cylinder requires compressed air for every direction of movement. On this type of cylinder, the force both the advancing and retracting direction is built up using corresponds air. The simplest way of acting a double-acting cylinder is by using a 5.5 way valve. The supply pressure is connected to the piston side of the cylinder, while the piston rod side is exhausted. The pressure on the piston side advises the piston rod. Once full extension is reached, the air pressure on the piston side reaches a maximum. Once the push button is released, the valve return spring pushes the valve into the initial position. The supply pressure is now connected to the piston rod side, while the piston side is exhausted. Via the exhausted point of the valve, the piston rod retracts. 3.6 5.5 way valve. The 5.5 wave valve has 5 points and 2 positions. The 5.5 wave valve is used primarily as control element for a control of cylinders. An example of the 5.5 wave valve, the longitudinal side valve uses a pilot spool as a control component. This connects or separates the corresponding lines by means of the longitudinal movements. The required acting force is lower because there are no opposing forces due to compressed air or spring. The 5.5 wave valve has advantage in passage construction and allows the exhaust bottom extension and retraction air for cylinders to be separately controlled. 3.7 Fittings and accessories. Pneumatic fittings are parts used to connect sections of pipes, tubes, and hoses in pneumatic pressurized gas system. Compared to hydraulic fittings, pneumatic fittings are typically characterized by tighter seals and lower pressure requirements. Pneumatic fittings especially donate the delivery of the power to control movement of pressurized gases, including air. In any pneumatic power system, the pressurized gas that drive the required mechanisms are typically delivered to where they are needed through an end network or right pipes, robust hoses, or lengths of flexible tubing. These systems and fittings are widely used today in all types of industries and applications, ranging from construction, assembly, and production line setups to a huge variety of industrial machinery, handheld tools, and workbench equipment. In many workplaces environments, the power that a pneumatic system delivers can often provide more versatile, reliable, cost-effective, and safer than equivalent setup powered by various electromotors and actuators. A pneumatic silencer is used to vent pressurized air to the atmosphere. They are commonly installed on a pneumatic wave cylinder valves, pneumatic cylinders, or fittings. Depending on the flow and the pressure of the air coming out of the exhaust point, the pneumatic air existing the device could produce noise that is particularly harmful to workers in surrounding environments or cause noise issues in the application. The third application. In addition to noise, the exhaust air may emit contaminants during operation. Using a silencer exhaust cleaner can prevent harmful contaminants from entering the environment. Students defined by organizations such as OSHA, Occupational Health and Environment Control Agency, are enforced by governments to help protect workers from harmful noise and contaminant exposure. Figures show examples of common pneumatic silencers. Pneumatic hoses are basically made of polyamide, polyurethane, polyethylene, but also PVDF and PTFE. The fact that they come in a wide diameter range and can be connected, among many other options, via push-in fittings made of nickel-plated brass, plastic, or acid-resistant steel, allows numerous possible applications in virtually all branches of the industry. Our company offers the pneumatic hoses in variable lengths sold by the meters and as well as complete pneumatic hoses assembles. Part 4. Flow pressure and wave valves. Learning outcome. Students will be able to understand the classification and characteristics of the flow, pressure, and step valves in order to put into the practice the knowledge acquired in this part of the pneumatic system. Timing 10 teaching hours. Description of contents by topics and subtopics. 4.1 Pneumatic training system. 4.2 One-way flow valve. 4.3 quick exhaust valve, 4.4. 5.5 motor stable valve, 4.5. 5.5 bistable valve, 4.6. 3.5 way roller lever valve, 4.7. Activities. Assessment criteria and procedure. Diagnostic evaluation. The diagnostic evaluation will take place at the beginning of the module and will serve to measure the degree of skills and abilities that students have. Formative assessment. Exam, written, oral, presentation, or projects, etc., 40%. Continuous evaluation, exercises, activities, tasks, and project presentations, 60%. Summative assessment consists of the sum of the exam and continuous assessment. Description and development of the content. 4.1 Pneumatic Training System. Perhaps someone may wonder how to get trained for pneumatics in school. The answer is that basic pneumatics learning system cover how to operate the installed basic pneumatics systems, analyze performance, and design basic pneumatic circuits. Pneumatic power is a foundation of industry used in application across the field like agriculture, pharmaceuticals, automation, and many more. The pneumatic training system requires a compressed air supply as it does in the industrial facilities. A pneumatic training system must include a mobile workstation, basic pneumatics panel, basic pneumatics instrumentation panel, and pneumatic hose and fitting set. This system uses industrial quality components for durability and to help learners prepare for what they will encounter on the job. Learners will use these components to study major topic areas such as pneumatic power systems, basic pneumatic circuits, principles of pneumatic pressure and flow, and pneumatic speed control circuits. The pneumatic training system covers basic pneumatic skills with the ability to add on systems to improve knowledge and skills. A pneumatic training must include an array of pneumatic components including cylinders, FRL, manometer, and many more. The learning system may include a mobile workstation construct of heavy-duty welded steel that provides storage space for additional panels and a lockable drawer for pneumatic hoses storage. 4.2 One-way flow valve. The flow control valve restricts or throttles the air in particular direction to reduce the flow rate of the air and hence control the signal flow. It should be possible to infinitely vary the restrictor from fully open to completely closed. The flow control valve should be fitted as close to the working element as possible and must be adjusted to match the requirements of the application. If the flow control valve is fitted with a check valve, the then function of flow control is unidirectional with full free flow in one direction. Flow control or one-way flow control valves regulate the piston speed of pneumatic drives during advance and return strokes. This is done through a suitable restriction of the flow rate on compressed air in exhaust air or supply air direction. In the case of one-way flow control valve, the airflow is throttled in one direction only. A check valve blocks the flow of an air in the bypass leg and the air can flow only through the regulator cross-section. In the opposite direction, the air can flow freely through the opened check valve. These valves are used to speed regulation of actuators and if it's possible should be mounted directly on the cylinder. 4.3 Quick exhaust valve. Quick exhaust valves are used to increase the piston speed of cylinders. This enables lengthy return times to be avoided, particularly with the same acting cylinders. The principle of operation is to allow the cylinder to retract at its near maximum speed by reducing the resistance of flow to the exhausting air during motion of the cylinder. To reduce resistance, the air is expelled to the atmosphere close to the cylinder via a large orifice opening. The valve has a closable supply connection 1, a closable exhaust 3, and outlet. Quick exhaust valves work by providing a rapid exhaust of controlled air when placed directly onto an air cylinder after control valve. The seal inside Clipper's quick exhaust valves is shaped like a bat wing. When air pressure is sent to the cylinder, it hits the back side of the seal and pushes the front of the side against the exhaust point. This seal is up and allows air to enter the cylinder. 4.4 5.5 monostable valve. The pneumatically actuated monostable valve 5.5 can be used as a control element. When used in an indirect control, the signal for extension of cylinder is initiated indirectly by a push-button 3.5 way valve, which supplies the control signal to the control element. 4.5 5.5 bistable valve. The 5.5 way valve has 5 points and 2 positions. The 5.5 way valve is used primarily as a control element for the control of cylinders. An example of the 5.5 way valve, the longitudinal side valve, uses a pilot spool as a control component. This connects or separates the corresponding lines by means of longitudinal movements. The required acting force is lower because there are no opposing forces due to compressed air or spring. The 5.5 way double pilot valve has the characteristic of memory control. The valve is a reverse form from 14 or 12 by means of reciprocal pneumatic signals. This new position is memorized until another unique signal occurs. 4.6 3.5 way roller lever valve. A 3.5 roller lever valve requires only minimal acting forces. The valve is returned to its initial position via the reset spring. As a cycling element, the directional 3.5 way roller lever valve is operated to detect the piston rod position of a cylinder. It can be considered as a pneumatic sensor. Part 5 Logic and timer valves. Learning outcome. Students will be able to identify the characteristics of the logic and timing valves and their operation in a pneumatic system. Timing 5 teaching hours. Description of contents by topics and subtopics. 5.1 Introduction to Blooming Algebra. 5.2 Shuttle valve. 5.3 Double pressure valve. 5.4 Timer valve. 5.5 Activities. Assessment criteria and procedure. Diagnostic evaluation. The diagnostic evaluation will take place at the beginning of the module and will serve to measure the degree of skills and abilities that students have. Formative assessment. Exam, written, oral, presentation, or projects, etc. 40%. Continuous evaluation, exercises, activities, tasks, and project presentations, 60%. Summative assessment consists of the sum of the exam and continuous assessment. Description and development of the content. 5.1 Introduction to Boolean algebra. Boolean algebra is a mathematics used to analyze digital gates and circuits. These laws of Boolean can be used to reduce and simplify a complex Boolean expression and reduce the number of logic gates required. Boolean algebra is therefore a mathematical system based on logic that has its own set of rules or laws which are used to define and reduce Boolean expressions. Pneumatic technology, like electricity, electronics, and so on, has digital equipment or devices that operate on binary principle. The term binary principle refers to the idea that many things can be true of as exist in only one of two states. These states are 1 or 0. The 1 and 0 can represent on or off, open or closed, true or false, high or low, or any other two conditions. The key to the speed and accuracy with which binary information can be processed is that there are only two states, each of which is distinctly different. There is no in-between state, so when information is processed, the outcome is either yes or no. A logic gate is a circuit with several inputs, but only one output that is activated by combination of input conditions. The two-state binary concept applied to gates can be the basis for making decisions. Valves at the processing level, the elements are dual pressure valve and function, shuttle valve or function. These functions are widely known in electricity and the same idea can be applied in pneumatics. Look at the truth tables below. 5.2 Shuttle valve. This non-return element has two inlets, 1 and 1,3, and one outlet 2. If compressed air is applied to the first inlet 1, the valve set seals the opposite inlet 1,3. The air flows from 1 to 2 inlet, 1 is closed. If air passes from 1,3 to 2, a signal is generated at the outlet. When the air flows is reversed, i.e. a cylinder or valve is exhausted, the seat remains in its previously assumed position because of the pressure condition. A shuttle valve permits the combination of two input signs into an OR function. The OR gate has two inputs and one output. An output signal is generated if pressure is applied at one of the two inputs. 5.3 Double pressure valve. The dual pressure valve has two inlets, 1 and 1,3, and one outlet A. Compressed air flows through the valve only if signals are applied to both inlets. One input signal at 1 or 1,3 blocks the flow due to the differential forces at the piston slide. If signals are appealed to both 1 and 1,3, the signal which is last appealed passes to the outlet. If the input signals are of the different pressures, the larger of the two pressure closes the valve and the smaller air pressure is transferred to the outlet 2. The dual pressure valve is used mainly for interlocking controls, safety controls, check function, and logic and operation. If one of the two end tires are released, the end condition at the dual pressure valve is not longer met. 5.4 Timer valve. There are very few industrial control systems that do not need at least one or two timed functions. Mechanical timing devices are used to delay events. Timers allow a multitude of operations in a control circuit to be automatically started and stopped at the different time intervals. In pneumatics, the combined functions of various elements can produce a new timer function device. An example is the time delay valve, which is the combination of one-way flow control valve, a reservoir, and 3.5-way directional control valves as shown. Depending on the setting of the throttling screw, a greater or lesser amount of air flows per unit of time into the air reservoir. When the necessary control pressure has built up, the valve switches to through flow. This switching position is maintained. As we said before in this book, the dotted line means enclosed in a package in only one device.